Alright guys, let me start with the multi-instrument and I'm going to arrange the one. And then I'm going to set the upper one is the oscilloscope and the lower one is the spectrum. So I'm going to set up the division and the time division as well to 40 millisecond and the amplitude to, let's just say, 50. And this one will gonna be 2 kilohertz. Let's just say like that. And then after this, I'm going to set up the QA401. Initialize the QA401. QA401 that has been in there, which is I initially open it. Alright, that's count. And then for this USB, I'm going to open the UT71E right now, initiate it, and then connect USB and get the sampling. I want to have the data acquisition every 5 seconds. So there you go. I put that. And what I'm going to do then is to, initially I have already opened the timer. So the timer is there. And I'm going to put somewhere in there. I cannot just fit it in. Tile. Heat sink is 24.2 degrees centigrade. And I'm going to start the unit right now. 3, 2, 1, plug in. And there you go. There is a signal already here, the sine wave. And what I can do in here is to expand so I can see the distortion. That's the best thing I can do. And of course, I can change the bolt for division here, which is, you see a little bit of the difficulty in using the PC-based equipment. That's why I need the patience in here. I'm going to put that one into 5, and that is also 5. And there you go. And that I'm going to put that into the spectrum. It's auto, so I'm going to put that into 2 kilohertz. So right now, this is the 1 kilohertz signal, sine wave. And the current signal right now in here is about 2 volt RMS. But in here, it's just only 1.7. So I'm going to trust this one. That will be like 2.2, 2.1. Well, not to be exact. So what's meant by that? This on the left channel is a 2.1 and on the right channel is also 2.1. That is the voltage swing at the 4 ohms resistive load. And the current distortion right now, I'm taking the total harmonic distortion plus noise, this one. And you get a pretty good distortion of 0.066 at the left channel and similarly for the right channel. So there you go. So, well, I think that is the most important waveform that I need to do when I'm doing a kind of a test or evaluation. And don't worry about this one because of the clock frequency. I missed or I did not show you about the clock frequency actually. That's not so much important right now. We know there is a clock frequency in class D. So let me see the temperature right now, which is just going up to 29 degrees centigrade. So what I'm going to do is to, at room temperature or when the heat sink is cooled down, I'm going to put the maximum voltage that can swing into the load at about, yes, something is wrong that I need to disconnect the input for the QA401 because it cannot go beyond 20 volts. That's 20 volt RMS. Let me just open the frequency counter. So I'm going to remove right now the QA401. It means to say that if I'm going to open the QA401 right now, there is no any input signal and the noise floor is about, let's just say about 118 minus 118 dBp. So I can just put this one into minimum and change the bolt for division on the oscilloscope to 50. The same on the left channel, we got 50. So there you go. And what I can do is to crank the input signal right now. And let's see the input signal or the output signal. Okay, let me maximize. All right, guys, 14 volt, 20, 22. Okay, we got 26, and you can see the signal at the tops and the bottom here is already distorted. That would be easier. So I think this could be like 1%, and probably this is like 10%. So again, maybe that one is at 1%, and this is at 10%. So that's how it is. And I'd like to set this one to about 20 volt RMS. Let's just say put it that way. That's the 20 volt RMS, which is mean to say that I have a maximum input in the QA401 so that I can make use of it. What is going on right now? I'm going to change again the spectrum to 2 kilohertz. Now you can see that the temperature right now is increasing, going up to 50 degrees centigrade. And let's see what is the QA401 right now. This is actually light, guys. No any trick right now. So I'm going to put an input right now. The that is the maximum input for the QA401 20 volt RMS. Now, if I say in here this 18, and what we can read in here is, what is it? All right, a 20. So I'm going to trust the QA401 21. There you go, 20. So, and let's just watch the temperature because that is very important. Now it's 62 degrees centigrade. Um, One thing that I did not do it is about the timer, the clock, which is still 00, because this is not a soft test actually. So I just evaluating it, and that's what we get right now. The three waveform, 69 degrees centigrade. So what is the power at 20 volt RMS? Voltage swing divided by 4, that is a 100. That is a 100. That's a 100 watt per channel. And that is too much. So I'm going to decrease that one to like about 20 watt of power. So what is 20 watt of power? So 20 watt multiplied by 4, and the square root of 80 is just like about 8 volt RMS. All right, so I'm going to put this one into 8 volt RMS right now. That's my sock test. This is what I like, so I can start the timer right now for the sock test. There you go, and start it. There you go. Actually, the most important right here, this is not so important on the spectrum because we don't monitor that one. So I can actually close this one or minimize it and maximize the temperature to be put in here, and then the timer to be put in there. And there you go. It's much better right now. Once again, guys, timer in here. Yes, there you go. Whenever I click that one, it goes. So probably what I can do is to there is seems to be no direct control in here or hotkeys, and maximize that one. Then much better right now, isn't it, guys? That's what I'm looking at. And I can expand this one and contract it. That's much better. Put this one into something like this. All right. Awesome, awesome, guys, awesome. That's it. So, 8 volt RMS, it will give you about 20 watt of power at the 4 ohms load. So it means to say that the left and the right is 40 watts per channel, and that will give you about 80 watts being consumed at the uh, main power supply right now. That's what I'm saying. And at that output level, power output level, we can see that the distortion is pretty good. It's a 0.034 for the left and similarly to the right channel. By the way, the yellow one in here is the left channel, and the blue one is the right channel, while the one in here is I can actually put that one into maximum so we can see it. So if we wanted to see the left channel only, this is the yellow one. And if I want to see the right channel, I can turn off that one and enable the right channel, which is the red one. And you can see that it will only display the distortion and the right channel. If you want to superimpose them together, you can have the left and the right channel together and minimize it so we can see both all the signals in one screen.
So I'm going to operate this power amplifier to 100 watt power to the left and to the right resistive load. And I have set up already in the PC-based tools. The application is working and the hardware is working as well. So the only thing for me to do now is to plug in the power supply, which is 321. And there you go. The killing point is almost there. There you are. Killing point is already shut off, and you can see the default LED. The default LED is already on, which means to say that I'm dead. I mean, I protected myself. I can guess right now that the temperature at the heatsink internally on the IC, that will be more than 125 degrees centigrade right now, while the surface temperature of the heatsink is just about 92.6 degrees centigrade. And to revive it once again, you need to plug in. Just make it sure that the temperature is now less than to 125 degrees centigrade. And we can actually confirm that one if we are going to plug it again, and we can see the output signal. Let's see. Yes, there you are. We still can see the output signal, and we can wait once again for the killing point. Well, of course, we can always do this all daytime because we have all the equipment. The only time that we have, I mean, the only thing that we don't have so much is about the time. So let's see once again the killing point. I always say about the killing point wherein this power amplifier, not only this power amplifier, but every TI Class D power amplifier that is coming out from the Taobao market, that's the killing point. That's the killing point at 95 degrees centigrade. So that is just nearly about 4 minutes, I should say. That's just only about 4 minutes. This power amplifier can deliver 200 watt of power into the 4 ohms load before it shut down itself. All right. One more thing is that when the amplifier shut down itself, the power being pulled in from the 220 volt AC line, that is about let's just say 10 watt of power. I'm going to remove it. And there you goes. There you goes. Nice experiment. There you goes. Nice experiment for the TPA3255. This is from Shure Electronics. This is one of the best Class D power amplifier that I have tested so far, with the best, one of the best performance actually.